So I am thrilled to be teaching you about right triangle trigonometry in this video, and you are going to love it. Okay, so first thing we have to do is establish some vocabulary. Okay, so I am going to start with a right triangle because what we're doing, we're only working with right triangles right now. So I'm going to start by drawing a right triangle, or as close to one as I can. We'll just pretend. And I am going to call this A, B, and C. And in general, that is how we label a right triangle, because the capital letters are the vertices of the triangle. And then what happens is the side that is across from the angle shares the letter, but with a lowercase. So side A is across from angle A, and side B is across from angle B, and then side C is across from angle C. Now, we know from earlier in math that this side of a right triangle is known as the hypotenuse, and that is still the same. So this side over here is the hypotenuse, and that is not changing. It also doesn't matter what perspective you are looking at, that is always going to be the hypotenuse. Okay, so now I'm going to do some color coding, because what's happening after that depends on what angle you are referring to and the perspective from that angle. So I'm going to start with angle A. So angle A is this one right here. All right. Now, when I am at angle A and I'm looking out towards this triangle, this side is the hypotenuse. This side is opposite from angle A, and this side is next to it, which the word we use is adjacent. So when I'm at angle A, this side is opposite, and this side is adjacent. Now, I know that this side is also adjacent, but that's the hypotenuse, and that overrides everything. So this side is adjacent to angle A. Now, when we talk about adjacent, we're talking about next to. So the classroom that is adjacent to mine is going to be 7B2 or whatever. So when we talk about opposite and adjacent, it's from the perspective of that angle. Okay, so from angle B, okay, so angle B is this one down here. Okay, this is still the hypotenuse, but this time, this is opposite and this is adjacent. So from angle B, this side is going to be the opposite side, and this one is going to be the adjacent side. So what you need to keep in mind is that the hypotenuse is always a hypotenuse, but these are going to change whether you are looking at the perspective of angle A or angle B. And that is so important in what we're doing. All right, next up, there are three main trig functions. All right, so three main, and trig is trigonometry, but you know, we're just going to abbreviate it. All right, three main trig functions. So first thing we want to do is make sure that you understand what trigonometry is and what it's doing for us. So here's the deal. Up until this point in your life, you know that you can find an angle of a triangle if you know two other ones, or maybe if you knew they were congruent, you could do some, manipulating with the numbers. We know with right triangles that Pythagorean Theorem will help us out to determine a missing side if we have two of them. But now trigonometry is going to allow us to relate the angles and the sides together. So maybe we know one angle and one side, we would be able to figure out the other angle and the other sides just by knowing one angle and one side. Okay? let's say we know two sides. If we know two sides, we can work backwards using trig to figure out the measurement of the angle that has those two sides described in it. So trigonometry allows us to use together the angles and the sides. All right, so it's huge. It's a very important part of math. All right, now there's three main trig functions, and you can always tell if a person knows what they're talking about by the way they pronounce them, okay? So you may have recognized or seen on a calendar, on a calculator, not a calendar, on a calculator, sin, cos, and tan. Well, those stand for sine, cosine, and tangent. So those are abbreviations, the sin, the cos, and the tan. But when we say them, we say the sine of blah, 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 or the cosine, blah, 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 whatever. All right, so we have sine, we have cosine, and we have tangent. All right, so those are our three main trig functions, okay? So this one is the one that on the calculator looks like sin. This is cosine, and on the calculator it says cos. And this one is tangent, which on a calculator says tan. All right, now, what happens is these three trig functions right here are going to connect an angle with two sides. Okay, so every trig function is going to connect an angle with two sides. So what we're going to say for sine is we would say the sine of angle blah, 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 whatever, angle A, angle B, or maybe it's 30 degrees, whatever it is, the angle measurement goes with the trig function. And it equals a ratio using the two sides. So this, for sine, we use the opposite over the hypotenuse. So anytime you hear sine, that is relating the opposite side and the hypotenuse from that angle. All right, cosine of the angle. So again, you know, you could be at angle A, you could be at angle B, it could be a totally different triangle, and you could be from angle Z, it doesn't even matter. But the angle measurement is going to go here, and the cosine is going to relate the adjacent side with the hypotenuse. So the ratio for cosine is adjacent over hypotenuse. All right, now last we have tangent, and you can probably take a guess that we're going to use opposite and adjacent because those are the two that haven't already been used. So we would have the tangent of the angle, and it is going to relate the opposite side with the adjacent side. So opposite over adjacent. All right, now, obviously I'm going to go through and work through some examples, but first you're probably thinking, how in the world am I going to remember this stuff? Well, I wish I could take credit for it, but I can't. And this has been around for like ever because I learned this when I was in high school. But there's a very, very, very cool way to remember the trig ratios, and that is SOHCAHTOA. So I'm right, it's so important. I'm using a fat marker. So we're going to do SOHCAHTOA. SOHCAHTOA. All right, now, SOHCAHTOA. This is an acronym that is going to help you remember which ones are which. Now, you have to make sure you know how to spell it. So this tells us that the sine is the ratio of the opposite and hypotenuse. The cosine is the ratio of the adjacent side with hypotenuse. And the tangent is the relationship or the ratio between opposite and adjacent sides. So SOHCAHTOA is going to be your new best friend. All right. So, and yeah, I mean, it sounds like she would be like an Indian princess or something, but she isn't. There's no exciting stories. This is just what comes out if you put all that together. You get SOHCAHTOA. So that's perfect. All right. So now let's do some practice. Okay. So first up, don't forget that we have something called Pythagorean Theorem that is still very important whenever we deal with right triangles. Okay, so don't let that leave your mind. All right, so example 1, here we go. And actually, maybe we'll use this triangle for a few of them. Okay, so let me give you some information first. So say ABC, and I'm going to tell you that is 5 and that is 12. I mean, no, sorry, that is 13. Oh my gosh. Although it would have been fine. We would have just muscled through it, but that's supposed to be a 13. Okay, so first thing that we need to do is we need to figure out this side of the triangle. So what we're going to do right now is just practice writing the ratios. We're not actually going to go through and find any answers yet. We're taking little baby steps here. So right now, we're just going to work with writing the trig ratios. Okay. Now, for any triangle, we can write 6 trig ratios, and I'll explain that in just a second. So first thing we need to do is figure out what this side is. Well, to do this, we're going to use Pythagorean Theorem. So if we think about this, so a squared plus b squared equals c squared, so that would mean c squared minus a squared is going to equal b squared, so b must be 12. All right, how's that? Hopefully you understood that. So I did c squared minus a squared to get b squared, and then if 144 is b squared, b is 12. Okay, so now what I'm going to do is go through some of the ratios. All right, so here we go. So if we want the sine from angle A, okay, if I want the sine from angle A, then that means I'm right here. So from angle A, the sine, so here, maybe we need to write this back up here because I'm on my next page. So, SOHCAHTOA. All right, here I'll separate them, little dots there. Okay, so if I want the sine, then I need to make the ratio of the opposite side and the hypotenuse. But it's from this angle. So from angle A, the opposite side is 5. So here, let's say the sine is opposite over hypotenuse. So the sine of A is going to be 5 over 13. And that's all that we're doing for today. All right. Let's say that I want you to find the tangent from angle B. Okay. So first of all, tangent is going to relate the opposite and the adjacent. So opposite over adjacent, but it's from angle B. So from angle B, the opposite side is 12. The adjacent side to angle B is 5. And I know it's not 13 because 13 is the hypotenuse. So the tangent of B is going to be 12 over 5. All right, let's say that I wanted you to find the cosine from angle A. All right, so SOHCAHTOA, cosine is right here. Cosine is going to relate the adjacent side with the hypotenuse side. So from angle A, okay, so from angle A, I want the adjacent side, which is 12, over the hypotenuse, which is 13. All right, so one comment I want to make is that we are not going to do sine, cosine, or tangent from angle C for a few reasons. First off, we already know it's 90-degree angle. So we already know that. So there's really no point in us going through that work. And then there's more to it actually than that, but you know, baby steps, remember? So we'll only be working with the other two angles, the two acute angles that are in the right triangle. All right, let's try another one. So for this triangle, let's say we have example 2. I'm going to draw this one differently, just, I don't know why, maybe I'll throw you off, who knows, right? Okay, let's see. Let's say this side is 9, this one we'll say is 13. We know that's C. We'll make this A and this B. All right, so first thing we have to do is figure out the missing side. So what we're going to do in order to do that is we are going to go through Pythagorean Theorem to get our hypotenuse is what we're looking on this one. So if we think about, so I'm just going to kind of go over to the side here. Let me change colors for a second. All right, so we need to do a squared, which would be 169, plus b squared, which would be 81. And that is going to equal c squared, which is 250. All right. So that tells me that C is going to be the square root of 250, which we could simplify to be 25 and 10, so 5 root 10. So this one will be 5 root 10. All right, so that was just doing Pythagorean Theorem to figure out our missing side. All right. Okay, so now let's say that I want you to, so let's see, let's do the sine of B. Okay, so sine of B. So if you think SOHCAHTOA, the sine of B is opposite over hypotenuse. Oops, almost put a B. Opposite over hypotenuse. All right, so from angle B, because it says we're using angle B, so from angle B, the opposite side is 9. The hypotenuse is 5 root 10. Now, we wouldn't actually leave it like this with the square root in the denominator. We talked about that when we did the special right triangles, but for now, we're just setting them up. So I'm totally okay with us leaving it like this for now. All right. Let's do the tangent of B. So if you think, if you think SOHCAHTOA, TOA is opposite over adjacent. So from angle B, the opposite is 9, the adjacent is 13. All right. Let's try the sine of angle A. So from angle A, the sine is opposite over hypotenuse. So from angle A, the opposite side is 13, and the hypotenuse is 5 square root 10. All right, let's do one more with the same triangle. Let's do the cosine of A. All right, so cosine is SOHCAH, C-A-H, so that is the adjacent over the hypotenuse. So from angle A, the adjacent is 9, and the hypotenuse is 5 root 10. So the cosine would be of A, from angle A, would be 9 over 5 root 10. All right, now, one thing I want to point out that is cool, but it's not like, you know, totally makes sense, is look at these two have the same answers. Well, they have the same answers, but if you look at them, it makes sense because the sine from B is going to use opposite over hypotenuse, which would be from angle A, the adjacent, and the hypotenuse, which would be cosine. So the sine of B is always going to be the same thing as the cosine of A. And the sine of A is always going to be the same as the cosine of B. So this one would be the same as cosine of B, because the opposite trig function from the opposite sine is going to be the same answer. And if you think about it, that'll make sense. Now, think about what will happen with the tangent. So how would the tangent of B be related to the tangent of A? Anyone? 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 You're right. They'll be reciprocals of each other, because the opposite and adjacent from B would be the adjacent and opposite from A. Very good. Good job. Nice job. Okay, so that'll take care of just the introduction, which is, again, just setting up the trig ratios and making sure that you can identify which sides go with which angles on the three trig functions. Good luck.